So that was an excellent discussion from Professor Prabdeep Kaur, and some of the points which he highlighted are food for thought, and I'm sure we can pick it up during the break and during our networking sessions. We move on to the next topic for today, Generative AI, pioneering the new era of intelligence. This will be presented by Dr. Saigeetha AJ, who is the Chief Data Scientist and AI/ML leader, AI and Analytics at IBM Consulting. Let me introduce you to her briefly. Recognized as one of the distinguished top 10 data scientists in India by Analytics India magazine, Dr. Saigeetha pioneered several FOAK AI solutions for resolving some of the complex problems in various industries like healthcare, automotive, banking and insurance, and others. A PhD in geophysical modeling, she has over 15 years of industry experience. She is currently engaged in the development of innovative solutions encompassing generative AI, application modernization using LLMs, healthcare content intelligence, and cognitive digitization. A recognized speaker and mentor, she is passionate about mentoring young students in the field of AI. In addition to her profession, she has interest in gardening and studying ancient temple architecture. Thank you very much. I welcome Dr. Saigeetha.
Good morning. First of all, apologies for taking some time here, since there are some videos which I wanted to play. A great time today, and very happy to meet so many women and great men and women here. So first of all, thanks for the introduction, and I'm also happy that my own mentor is here, Professor Annapurni Subramaniam, under whom I did my internship during my 20 years back at Indian Institute of Astrophysics. So it's a great time to be here, and thank you, ma'am, for all the guidance. So today, I think we'll spend next 1 hour on understanding how our future would look like. I think you would make out right from the topic that we are going to talk about. It's generative artificial intelligence. So it's not going to be technical. I'll keep it as simple as possible. But this is to give a glimpse of how our future would look like in the coming days, and what are we how are we going to implement or see the usage of artificial intelligence and, more specifically generative artificial intelligence in the coming years, right? That is what we will look at today. There is a saying, right, in Tamil, Anuvur Kanuvai Appalu Kappala. This has been written 2000 years before by a women poet. It's a Sangamera poem, which says with the power which permeates the smallest of atom and also even larger than the universe. So we are looking at a kind of a new era of intelligence that's opening up, that is permeating both physically as well as virtually, psychologically. So that's what we call it as the generative artificial intelligence. I'll take some time to talk about what is artificial intelligence. I know many of you would be aware of it, but just to keep it in a flow, I'll talk about a bit about artificial intelligence, how it evolved, and then what is generative artificial intelligence, how is it being applied in various domains and industries right now, and what are the ethical considerations, because so many of us have different questions and doubts about the challenges, risk associated with it, and what is the future with regards to that. These are some of the key things that I would touch upon. And also, please stop me if you have any question. At the same time, I'll try to keep it more interactive as possible. This is a friend of mine. She's Cogni, and let's see what she does.
Namaste. I am Cogni. I am a part of cognitive team under Dr. Kinshuak Banerjee. Welcome to my first presentation. I am a little nervous. Shall we start?
Yes.
GBS Cognitive Sandbox. The GBS Cognitive Sandbox is a shared sandbox environment. It gives our global CBDS cognitive practitioners with access to software, infrastructure, and Blumensplots and developer cloud services. This is without consumption or resource constraints of any kind. Should we move to the next slide? Moving to the next slide. Cognomics overview. Oh, this is my favorite slide as I don't have to speak much. Now I would like to ask Dr. Kingshuk to elaborate on this topic. Thanks, Kingshuk. That was a great overview. Let me now take over. CBDS Wiki Rewire and campaigns. The following thoughts and ideas are key to the Wiki engagement strategy. The strategy is based on 3 key elements, namely increased collaborative working, gamification, and peer-to-peer recognition. That's it from me for today. Let me thank you for your participation and providing me an opportunity to interact with you.
Okay, leave the content, what it spoke, right? But what did we make out of this video? Right. You can see a robo powered by a generative AI, which can read the slides, understand the content through its camera, it can read, and understand what it needs to speak, and generate a content out of its own, and speak in a human-like language, is what is happening. So this is what is called artificial intelligence, right? The intelligence that mimic the human intelligence, or try to mimic, I won't say completely mimic, but at least try to mimic what is possible by human intervention, both from intelligence, like, perception, generation, and also decision making. Okay. This I thought I'll put you, these images have been generated by a generative AI. How many of you had played around with ChatGPT? Yeah, many. So you would know like how it can generate the content if you give an instruction. Suppose this is not ChatGPT, this is DALL-E. I asked the model to generate a picture of an Indian city 2000 years back, older one. So this is what it generated, and possibly 2000 years from now on, how our Indian city would look like, and that is what it shows. So this is without any kind of training, just with the instruction it is able to generate. So that is why we call it as generative AI. So we have evolved. That's what I will be talking about. Before moving on, where it all started, right? Several decades back, humans started thinking, there is so much data that is available in your mobile phone, in all your smart appliances, in your computers, everywhere, bank, your healthcare, everywhere, there is so much data available. And can this data be utilized for, something very useful? That is what the thought process that came into our mind. In fact, Stephen Marsland says that if data has mass, the earth would be a black hole, because that is the amount of data every day we generate. So by 2020, In fact, 44 zettabytes of data were generated. In fact, now it is much more, possibly tripled by the time like we are in 2023. This is the amount of data that we generate. Data can be in the form of photographs, videos, in hospitals, your patient data, it can be data from your labs, data can be anything. So much data is generated and stored, and how can it be used? Something for human, for the advantages or to resolve some of the very complex problems. That is the thought process that came into mind. That is where the whole data science as a domain started growing. Data can be of multiple types, right? We talk about structured data, unstructured data. And this is not very simple. This is very complicated in nature. So data can be in a structure format like your Excel sheets, where the data can be like one-on-one, you can map it, easily understand. But at the same time, 80% of your data from all your appliances, from your smartphones or anywhere, it would be available as unstructured data. It can be documents, it can be pictures, it can be videos, it can be audios. So it can be of anything. So 80% of your data is unstructured. That's where this opened up an entirely new kind of dimension called artificial intelligence. Because to understand the unstructured data, a certain level of intelligence has to be there, and that's where machines were trained with an artificial intelligence that can mimic the human intelligence. Now, what you see here is a comparison, right, of how a human brain would look like, a simplistic, a representation of our human brain, and how an artificial brain, or I would call AI brain sitting in your chips, that would look like. Can you see the similarity? So what you see here is we are trying to create a system that is physically as well as virtually similar, right? Efficient, both from efficiency as well as structure-wise, similar to what we have as a human brain. So that is what we are going towards, where we can we try to create a system that is very similar to human. Okay, before moving on to, I will talk about, I'm actually going to, in the next slides, I'll be talking about human intervention. How do we control? Because there are lots of risk associated. So how do we control the artificial intelligence? In what mechanisms or what ways we can control them? So I'll talk about that. So this one shows a kind of a high-level understanding of how everything is evolved, right, in the artificial domain space. So it all started in 1950 by a scientist called Alan Turing. So what he did, it was a very simple experiment he did. Very simple, but he wanted to try out whether a machine or a computer can in future have such kind of intelligence, right? Can we start thinking in that space? So he did an experiment called Turing's test, wherein what he did, he split a room into two halves. In the first half, he put a human interrogator. In the other half, he kept two. One a human and another machine. The machine would be switched off when the human is interacting. And when the system is interacting, the human would be moved away from the room. So basically, at least one would be there. What he did was, the interrogator started asking questions, and the human responded. The same questions he started asking to the system. He wanted to see if system with certain amount of inbuilt algorithms or logic, can it reply, at least to a certain extent, to what human does. And though it was not a very successful attempt, but he could see a glimpse of a ray of hope that it was in fact with additional logic and with additional training, it can do a portion of what human can think and perceive. So that is the first known experiment of artificial intelligence. And that is where it all started. So we have analytics, statistical way of analyzing the data. Then moving on, what we call as machine learning. The name itself is self-explanatory, where the machine is trying to learn certain things that just like a baby learns, right? A child learns, okay, this is car, this is light, this is fan, this is room, this is a human, this is men, women, kind of. Can the machine be actually trained, or that learning can be given? So that is what is called machine learning. So that was like maybe 3 decades back we did. Then moved on to have a much higher version of deep learning, right? Most of your smartphones all contain deep learning models where it can actually, voice calls that come in, chatbots in your banking, insurance, websites, what you see, or your hospital, all are driven by this. And then we are moving much, much beyond with the generative AI, where this is we are standing at a transition point where the machine just not, like previously, right, till 2 years back, whatever we asked the machine to do, it would do. Whatever we have trained the machine to do, it would do. But we have moved into a space where the machine can generate itself with less intervention. That is where the risk also come into picture to your question, how do we intervene? So this is where it is both advantageous and highly disadvantageous as well, and that's where a lot of governments, Government of India, European Union, all are bringing their rules, regulations to regulate the usage of generative AI, because this is much, much more powerful than what we used to do before. Have a question? Sorry. I'll just skip this. This is to show you how this all evolved. Okay, so what is generative AI? I'll talk about this and then move on to the applications. The name itself denotes, right, generative artificial intelligence. The artificial intelligence, or the systems that are powered with this, can generate content. It can generate images, it can generate answers, it can generate documents, it can generate decisions, it can generate anything and everything. That is why it is called generative AI. And to give you, like you may ask, what is the difference between what we used to do with all our, I think many of you might have heard of machine learning algorithms. What is the difference between this and this, right? It's all the same. No. What we used to do before, okay, I wanted to train a model to differentiate between 50 types of cars. Say I have 50 car makes that are running on the road, I wanted to differentiate. So what I do, I used to collect 200, 300, 400 images of each of them, feed into the system. It learns through, that is what is called machine learning. It learns, and then when I give a new image, it would identify. But what is happening right now, what we call as foundation models, that means these models are so huge, they are the foundation models, they have been trained on enormous amount of data. The ChatGPT is trained on 13 trillion parameters. It is not 1 or 2, but 13 trillion parameters. And some of the biggest models are 70 billion. And this is going to increase a lot because so much investments are going on. So when it comes, imagine I have a child, I'm a teacher, a child come to me for learning. The child knows nothing. I start from the scratch, I teach it. I teach the child with every information. That is machine learning. Now imagine I get a child in my class that has already been that has already learned on so much of information. That is where we are. The generative AI, the foundation models are already trained. So it has the ability to do even beyond what you are expecting sometimes. So that is where we are, and we are in a very, very very important time where everything is going to be influenced by this invention. This is a very simplistic, whatever I explained, very simplistic explanation, right? I used to have, suppose I need to do 3 things. I have to train models for every step. For example, I'll give an example, right? For one of the car insurance client, we built an AI tool. The tool needs to first identify the car. That is the first thing. Second, it needs to understand if the car is, say, this is for a damage detection tool. So the tool needs to understand if the car is damaged. That is the second step. Third step is whether in which part the damage has been, it has been damaged. So is it windshield, or is it a door, or whatever, right? So for every step, I used to train models. So it used to be a big tool that we used to build. But what you see here, I will have one model that does everything. That is why it is called foundation models. And another part of the, or another advantage is, it comes with pre-learning. That means it has already learned to a great extent. As I said, 13 trillion, 70 billion kind of the scale that we are talking about. So where are, right now, since this is more of a very initial stages of, still we are figuring it out, right? Where and all it can be used, what are the advantages, what are the limitations, what are the risks. We are still trying to understand and get, trying to understand this both from government, both from the user perspective, and also those who develop as well. Some of the key areas where we are currently implementing across domains. It can be healthcare. I'll talk about a couple of use cases in healthcare, how we are implementing the generative AI models, particularly in the drug discovery and health insurance. I'll talk about it. It can be the software development, it can be healthcare, it can be supply chain, it can be ethical aspects of it. So everywhere, the generative AI is going to play a major role. Wherever we thought the technologies that we were doing till this date is not providing good results for us, that is where the generative AI may help us, particularly very complex scenarios like drug discovery. And this is also one major thing, right? I keep showing them. As I mentioned about how the traditional ML is different from generative AI, you can see the amount of reduction in the time and effort. Almost 70% you are reducing. Otherwise, we need to go through all the steps one by